Hi friends, welcome to another video lecture of this present module. We shall solve some problems based on the transformation of random variables. Okay, I shall be sharing this material with you shortly. The equations that we had derived and mentioned for the transformations of random variables play a very important role. We need to remember all the formulae here in order to solve the problems. First problem goes like this. The variance of the zero mean random variables capital X and capital Y are given as 7.05 and 5.36 respectively, and also given that the correlation coefficient for X and Y is rho xy is equal to minus 0.48. The bivariate random variables capital U and V are obtained with the transformation U is equal to 2x plus y, V is equal to x plus 2y. So find the correlation coefficient rho u V. So the transformation U is of the form ax plus by, V is of the form cx plus dy. This is U. Okay. Okay. This is U. This is U is equal to ax plus by, V is equal to cx plus dy. Now compare this U given equation U is equal to 2x plus y. Compare U is equal to 2x plus y with U is equal to ax plus by, and compare V is equal to x plus 2y with V is equal to cx plus dy. That is, compare this equation with this equation with this. So by doing so, I can get the coefficients of A, B, C and D. So by comparing U is equal to 2x plus y with U is equal to ax plus by, I see that A is equal to 2, B is equal to 1, C is equal to 1 and D is equal to 2 is obtained by comparing V is equal to x plus 2y with V is equal to cx plus dy. Okay. So that's about this criteria. Then moving on further. Now write the corresponding data that has been given. So variance is sigma variance of x is sigma x squared is equal to 7.05. The variance of y is sigma y squared is equal to 5.3x. The correlation coefficient between x and y is rho xy, which is equal to minus 0.48. I have just written down the data that has been given. Now I have to find the correlation coefficient rho u v. So first find the correlation between x and y. So correlation between x, the covariance between x and y is given by COV of xy, which is equal to rho xy into sigma x into sigma y. Now sigma x, I need to write down. Sigma x is nothing but the square root of the variance. The sigma x is the standard deviation of x. It is given by the square root of the variance of x, so that is equal to square root of 7.05. Next, I have to find sigma y. Sigma y is the square root of the variance of y, that is sigma y squared. So this is given by square root of 5.36. So sigma x is given by square root of 7.05, sigma y is given by square root of 5.36. So now I shall substitute this sigma x, sigma y and rho xy into this formula. By substituting, I get this. Covariance of xy is equal to minus 0.48. This is given. Minus 0.48 is already given in the problem, right? As given here. So minus 0.48 into square root of 7.05 into square root of 5.36. So covariance of xy is found to be equal to minus 2.9507. Okay. Now moving on further. Now find the variance of u and find the variance of y. That is the new transformed random variables. So I shall use the already existing formula that we mentioned previously. So sigma u squared is given by a squared sigma x squared plus 2ab into covariance of xy plus b squared into sigma y squared. Substitute the corresponding values. I get sigma u squared is equal to 21.7572. Right? What data has been written here and what covariance of xy has been found out. Substitute, get the result. That's all. Use your calculator, get the result. Similarly, find the variance of the new random variable v. So the formula is sigma v squared is equal to c squared sigma x squared plus 2cd covariance of xy plus d squared into sigma y squared. So substitute the corresponding values. So and simplify, I get sigma v squared is equal to 16.6872. Now find the covariance of uv. Because the correlation coefficient of uv, u and v is dependent upon the covariance of u and v. So it is imperative on my part to find covariance of uv. So that is given by ac sigma x squared plus ad plus bc into covariance of xy plus bd into sigma y squared. Okay, now substitute the corresponding values. A is equal to 2. So covariance of uv is equal to 2 into 1 into 7.05 plus 2 into 2 plus 1 into 1 into minus 2.9507 plus 1 into 2 into 5.36. Okay, so you please be careful to take the positive and negative values as and when required. Here covariance of xy is given by minus 2.9507, so please be careful to use the minus sign. Okay, so simplifying, I get covariance of uv is equal to 10.0665. Next, find the correlation coefficient of uv. So correlation coefficient of uv is given by covariance of uv divided by sigma u into sigma v, where sigma u and sigma v are the standard deviations of the new transformed random variables u and v respectively. Okay. Now sigma u is given by square root of sigma u squared. So that is given by square root of 21.7572. Sigma v is given by square root of sigma v squared. So this is given by square root of 16.0665. So substitute the values of covariance of uv, sigma u and sigma v. Sigma u and sigma v are the standard deviations of u and v respectively. So substituting and simplifying gives me rho uv is equal to 0.5283, which is the final answer. Verification is that the correlation coefficient should always lie between -1 and +1 only, right? So that's the verification. Thank you. Just a minute. Okay. So next problem we shall continue in the next video. Thank you.